In this lecture video we are discussing about this free radical substitution or free radical substitution reaction, and this free radical substitution reaction is effective for MSc level. And here in free radical substitution in MSc level we have to understand at first free radical mechanism in general, and here in MSc level we have to study free radical mechanism, free radical substitution mechanism in general, and free radical substitution reaction in aromatic substrate, and next free radical substitution in another we have to study here neighboring group assistance in free radical substitution reaction. And first here we are discussing about free radical mechanism in general. In general, what happen in free radical mechanism, at first we have to understand what is free radical. And suppose when we take HCl molecule, this is covalent molecule, HCl, this is covalent molecule, HCl molecule, because hydrogen non-metal, chlorine non-metal, both are non-metals, and when two non-metal combine, and then there is formation of covalent bond. And in the valence shell of hydrogen there is one electron, in the valence shell of chlorine there is one electron. And when hydrogen and chlorine combine each other, what happen, in between non-metal there is mutual sharing of electron, and in this mutual sharing hydrogen give one electron in between the chlorine, and chlorine give one electron in between hydrogen and chlorine. What happen in between hydrogen and chlorine, here sharing of one pair electron, and when one pair electron is shared in between atom, there is formation of one covalent bond. And here this chlorine maintain octet inert, hydrogen to plate inert, so in between HCl there is mutual sharing of one pair electron or one covalent bond. And when we carry out here a homolytic bond fission, homolytic bond fission, two type of bond fission in organic chemistry, one homolytic, another heterolytic. And now come to here homolytic bond fission. What happen in homolytic bond fission, here in between hydrogen and chlorine there is mutual sharing of one pair electron, and this one electron is obtained from hydrogen, one electron is obtained from chlorine, and in the valence shell of chlorine there is three lone pair non-bonded electron. But in homolytic bond fission, what happen, one electron shift towards hydrogen and one electron shift towards chlorine, means each atom gain one electron, shear pair electron, then hydrogen gain one electron, chlorine gain here one electron, here remaining three pair electron in the valence shell of chlorine. Then this is called free radical, and this type of bond fission is called homolytic bond fission. And here in homolytic bond fission, what happen, chargeless species is formed, hydrogen and chlorine, because here in this here pair electron, one electron obtained from hydrogen, one electron obtained from chlorine, and chlorine take its shared electron, hydrogen also take its shared electron in the bond fission, so there is no formation of charge, and this is chargeless. And here hydrogen contain how many electron in its valence shell, 1, chlorine contain 2, 4, 6 plus 1, 7, means both contain even number of electron, even number of electron in its valence shell, and the chargeless species having even number of electron in its valence shell are called free radical. And this H plus, this hydrogen free radical, and when we observe in this chlorine, it also contain even number of electron, 7, and chargeless, this is chlorine free radical. And if you understand what is free radical, how this formed by homolytic bond fission, and this homolytic bond fission takes place in presence of light SB or UV, in presence of light, high temperature, at high temperature there is homolytic bond fission, in present high temperature a gas phase, when we carry out reaction in gas phase, there is also homolytic bond fission. When we take inert solvent, non-polar solvent like CCl4, carbon tetrachloride, CS2 carbon disulfide, there is homolytic bond fission. And when we have attacking reagent, free radical, at that case there is homolytic bond fission. Clear condition of homolytic bond fission and what is free radical and how this free radical is formed, we have discussed here. And now come to another section, that is free radical mechanism in general. And here what is a general free radical mechanism? Suppose when we react Rx, this is, suppose this is reactant, and here Y radical. Suppose Y, this is free radical, and when we carry out reaction in presence of attacking free radical, this is reactant molecule, this is attacking reagent, here attacking reagent free radical, then there is free radical mechanism Ry plus X radical. When reacting substrate is attacked by free radical, then there is this leaving group also removed as a radical, and this is called, here Y substitute X, therefore this is substitution reaction. In this mechanism, the attacking reagent is free radical, therefore this is called free radical substitution. This is free radical substitution. And when we observe free radical mechanism in general, now come to example. Suppose when we take CH4 molecule plus Cl2 chlorine in presence of light, when in presence of light it react to give what is complete reaction, CCl4 plus HCl 4, here 4, this product is obtained, and in presence of light there is homolytic bond, so free radical mechanism. And in free radical mechanism there is 3-step process. In all free radical mechanism there is 3-step process. First, chain initiation, and what is second? Chain propagation, and what is third step? Chain termination. In free radical mechanism in general, when we carry out free radical mechanism in general, there is, or in any free radical substitution reaction, always there is 3-step process. This is step first, chain initiation, step second, this is chain propagation, and step third, this is chain termination. And here in this chemical reaction, at first what happen in presence of light, this Cl2 molecule in presence of UV light, that dissociate to give chlorine free radical, because here Cl2 molecule, each chlorine atom contain 3 non-bonded pair of electron, 1 2 3, and here another chlorine also contain 3 non-bonded pair of electron, 3 lone pair, and in the valence shell of chlorine atom there is 7 electron, here also 7 electron. When Cl2 molecule is formed, there is mutual sharing of 1 pair electron in between chlorine atom. What happen in presence of light? There is homolytic bond fission. In homolytic bond fission, 1 electron shift towards 1 chlorine atom and another towards another chlorine atom, then it give 1 2 3 4 5 6. Here already this chlorine contain 3 lone pair, and 1 electron is obtained from this here pair electron. Another chlorine contain 3 lone pair electron, and 1 electron is obtained from this homolytic bond fission. And in homolytic bond fission there is formation of chargeless species. These both are chargeless species. And here how many electron? 1 2 3 4 5 6 7. means even number of electron in its valence shell. Chargeless species having even number of electron, this is called free radical. Free radical. Or here which one contain radical? Chlorine. So this is chlorine free radical. And how to represent this chlorine radical? These pair electron are not represented. Simply here chlorine contain one odd electron. These three are pair, but this is on pair, and this chlorine radical are represented by this symbol Cl. This is Cl radical. This is Cl radical. And these free radical are highly reactive. And when we observe here in Cl2 molecule, this chlorine maintain octet state, this also maintain octet state, but when homolytic bond fission takes place, then here this chlorine radical contain only 7 electron in its valence shell, incomplete octet, therefore unstable and highly reactive. And these free radical are highly reactive. And formation of the highly reactive chemical species, this is chain initiation. This is chain initiation step. And what is chain initiation? Formation of free radical. This is called chain initiation. And now see in chain propagation, what happen in chain propagation? In chain propagation, we are reacting CH4 methane and Cl2. Therefore, this Cl free chlorine radical, this chlorine radical react with another neutral species. Here what happen? When this Cl and Cl again combine, then there is formation of Cl2 neutral molecule. This is chain termination. But due to high reactivity of this free radical, it react with chemical species which it meets. At first it react. If radical meets radical, there is chemical reaction. If radical meets neutral chemical species, it also react with neutral species, because these radical are highly reactive. And what happen in this free radical? This chlorine react with hydrogen or carbon. Here this chlorine is more exposed towards hydrogen. चेन इनिशिएशन कंप्लीट, चेन प्रोपागेशन. यहाँ इस चेन प्रोपागेशन पे क्या होगा कि ये फ्री रेडिकल हाईली रिएक्टिव, इसमें ऑक्टेट स्टेट मेंटेन नहीं है. ऑक्टेट स्टेट कंप्लीट नहीं होगा तो वो हाईली अनस्टेबल, मीन्स हाईली रिएक्टिव. एंड दिस हाईली रिएक्टिव स्पेसिस रिएक्ट विथ CH4 molecule. And what happen in this CH4 molecule? A chlorine, this chlorine when attack on this hydrogen, जब ये क्लोरीन इस हाइड्रोजन में अटैक करेगा और दिस क्लोरीन अटैक ऑन कार्बन, तो दिस क्लोरीन इजीली एक्सपोज टू दिस हाइड्रोजन. एक क्लोरीन यहाँ कार्बन पर अटैक करने जाएगा तो क्लोरीन इन बिटवीन क्लोरीन हाइड्रोजन देयर इज स्टेरिक इफेक्ट. यहाँ जाएगा तो ये हाइड्रोजन इसको ब्लॉक करेगा, क्लोरीन को यहाँ पे जाने नहीं देगा. तो this chlorine more exposed towards this hydrogen, and when this chlorine more exposed towards this hydrogen, then this radical abstract hydrogen from this CH4 molecule. And what happen in this molecule? Here attacking reagent radical, then here bond fission takes place by homolytic bond fission. Then when one electron shift towards hydrogen and another electron towards carbon, it gives CH3 radical and H radical, and this H radical combine with Cl radical. And when H radical and Cl radical combine, give hydrogen give one electron in between hydrogen chlorine, chlorine give one electron in between hydrogen chlorine, then there is formation of HCl neutral molecule, and here formation of methyl radical. This is chain propagation. What happen in this chain propagation step? Always always this radical abstract or withdraw radical from neutral species. Here Cl radical abstract hydrogen from this CH4 neutral molecule and combine with hydrogen radical to give HCl radical, then there is formation of CH3 radical. And this chain propagation, in second step of this chain propagation, what happens, CH3 here radical is formed, and this radical when combined with another radical there is chain termination. But what happens in chain propagation, one radical combined with another neutral molecule. When chlorine form radical, then it attack with neutral halogen part, hydrocarbon part, and when this hydrocarbon part form radical, then that attack in Cl2 neutral molecule. And here CH3 radical and Cl2 radical, here what happen, CH3 radical then here what is actual chain mechanism in chain propagation step, always radical abstract atom or group of atom from neutral species, and in neutral molecule there is result in the formation of radical. And here the CH3 radical Cl2 neutral molecule, then this radical abstract atom means that abstract one chlorine from Cl2, then it gives CH3Cl plus Cl radical. And in next step what happen, which one is neutral molecule CH3Cl and which one is radical Cl radical, and what happen in this step, radical always abstract radical from neutral species. Here this is neutral, and from this neutral molecule this radical with abstract means withdraw hydrogen, then HCl is byproduct, and when give HCl byproduct, then here CH2Cl radical is formed, CH2Cl, one hydrogen is removed from CH3Cl, then CH2Cl radical. And again this is radical, CH2Cl is radical, and this radical again react with, here in hydrocarbon part there is radical, then that attack in neutral halogen molecule, again this radical withdraw abstract one chlorine, then CH2Cl2 neutral and Cl radical. When one Cl is abstract by CH2Cl, here release of Cl radical, again which one neutral molecule, CH2Cl2 plus Cl radical, again radical, this is radical abstract atom from CH2, here Cl2, not this is CH2Cl2, again one chlorine abstract hydrogen, then it give HCl byproduct. Here when one hydrogen removed from this species is give CHCl2 radical, again this CHCl2 is radical, this is radical, then this radical again combined with neutral halogen molecule, and this radical abstract one halogen from this neutral species, then CHCl3 plus Cl radical. Again in next step what happen in this chain propagation, in next step this is neutral species CHCl3 plus Cl radical, this radical abstract atom from here, then CCl3, when hydrogen removed from here CCl3 radical plus this radical and one hydrogen radical give HCl. This is chain propagation in CH4. And simply in general, in free radical mechanism in general, what happen in, there is chain initiation step. At first there is formation of free radical which is highly reactive, and always in second step what is chain propagation, and what happen in this chain propagation, always one radical and another neutral molecule participate in the chemical reaction to increase the chain or length of chemical reaction. Always one radical, one neutral species when involved in chemical reaction, this is called chain propagation. And what happen in chain propagation step, always radical abstract or withdraw radical from neutral species. Here Cl radical with abstract withdraw hydrogen radical then give HCl, then here formation when this hydrogen is removed keep CH3 radical. Again which one radical? Here hydrocarbon part contain radical, then this hydrocarbon radical, here if chlorine give radical react with neutral hydrocarbon, if hydrocarbon part give radical that react with neutral Cl2 molecule, because in reaction system there is number of Cl2 number of CH4 and here all molecule are not dissociate to give radical, there is also neutral molecule. Then this hydrocarbon radical again when react with Cl2, then this is radical and that withdraw or abstract atom from neutral, this is Cl2 here neutral, when this CH3 take one Cl from here, then CH3 neutral molecule is formed, then there is formation of radical. Again which one neutral? This is neutral, Cl radical, and this radical again withdraw hydrogen, then HCl gives, when we remove from CH3 Cl2 one hydrogen CH2 Cl radical. Hydrocarbon again form radical, then it react with neutral alloalkane. Again alloalkane give neutral molecule, hydrocarbon neutral, then halogen radical, in hydrocarbon shift radical. Again when hydrocarbon form radical react with neutral halogen give neutral halogen hydrocarbon molecule or derivative of hydrocarbon. Again this is neutral and that react with Cl radical to give CCl3 plus HCl. These are called chain propagation. And what happen in chain termination? When Cl radical plus Cl radical combine give Cl2 neutral molecule, this is propagation. Propagation means end, there is end of reaction. Or when CH3 radical plus Cl radical combine, then CH3Cl. In this chemical reaction in research or when in microscopic study there is trace ethyl product is obtained. How this ethyl product is obtained? CH3 radical plus CH3 radical give C2H6 ethane in trace, not in excess. And the chemical reaction in which two radical combine to give neutral molecule, this is called chain termination. There are various type of chain termination. When these Cl combine, Cl2 CH3Cl, CH3Cl, when this CCl3, this is major product. Which one major product? CCl4. When this CCl3 combine with another Cl radical give CCl4. This is free radical mechanism in general. What happen in this free radical mechanism in general? There are 3 steps in all free radical mechanism: chain initiation, chain propagation, chain termination. Initiation, that means formation of free radical. Chain propagation means increase in chain length, and this is special in this free radical mechanism. And what happen in this chain propagation? There is always reaction between neutral species and radical, and that result in the formation of radical and again neutral species. And always radical abstract free radical from neutral, result in neutral molecule. Here Cl give radical give neutral product, and this neutral molecule give radical. This is chain propagation. Increasing of chain, this is chain propagation. And in chain termination, what happen? Two radical combine, then there is completion of reaction. And in this video we have discussed about this general